Next up, we have exponential functions, and I'm not gonna lie, this is gonna be really easy, because you only need to know 3 equations. So let's get started. Our first one is going to be standard form, where f of x is equal to a times b to the power of x. And here, a is going to represent your y-intercept. So if you ever need to write an equation in standard form, you should know that a is going to be your y-intercept. Or in a question, if you see an equation written in standard form, then once again you should know that a is your y-intercept. Then for our next equation, we have exponential growth, where p of t is equal to p sub 0 times 1 plus r to the power of t. Here, this p0 is going to represent your initial value. So let's say you started with $10,000 and gain 10% every month. That $10,000 or your starting value is going to be p0. And this also goes hand in hand with your standard form. So your initial value would also be your y-intercept if you had to graph it or something. Then this t represents your time. So it could be years, months, hours, minutes, seconds, any unit of time. And then 1 plus r is going to be your rate of growth. So using that old example, if we gain 10% every, month? If we gain 10% every month, then it would be 1 plus 10%. And the important thing to notice here is that you're always going to be adding from 1, which means that that number inside your parentheses will always be greater than 1, no matter what. So if you ever see that the number inside the parentheses is greater than 1, you should instantly know that it's going to be exponential growth and that your number will always be increasing. That p of t, that final value, will always be a bigger number. It will always be increasing. And then lastly, we have exponential decay, and this is going to be the exact same equation, except we're subtracting r now instead of adding, because, well, it's decay. So p0 is still going to be your initial value, t is still your time, and now 1 minus r is going to be your rate of decay. And the important thing to notice here is that you're always going to be subtracting from 1, which means that the number inside the parentheses will always be between 0 and 1. So it's always going to be a decimal between 0 and 1. So like 0.23, 0.3, 0.9, that type of stuff. And that means that if you ever see that the number inside the parentheses is going to be a number between 0 and 1, you should instantly know that it's going to be exponential decay, and that your final value, or that p of t, is always going to be a smaller number because it's decreasing. Alright, those are the only 3 equations that you need to know for exponential functions. The standard form, exponential growth, and exponential decay. Well, I mean, I guess you really only need to know 2, right? Because all that changes between growth and decay is that plus and minus. So yeah,